Hi guys, I hope you're good since last video. We have seen the mini TUI app to read a file and went through the code in our first video. Then we have seen how the Kubernetes version upgrader project is organized with the folder structure, and it was pretty interesting. Now we are going through looking back and seeing what could have been improved, and goes through also 15 lessons that I've learned doing this project, and this is why building is the best way to learn Rust. We do this so that in next videos, when we are going to run the TUI app, upgrading my Kubernetes cluster, we will have all that background knowledge about it. I've left a link in the bio for the students who want to learn AI by doing, beginner devs want to think at a service that they could offer, or business owners who want to use AI for themselves. It is free. There is a guide PDF to download on the video. Link is in the pinned comment and video description. Get it now from our hub, Checker Houses. Also, please like and subscribe. Thank you for your support. Open your terminal. Let's get started. Behind the scenes and the improvements. So let's just start with my different checklists that I had. I had the learning checkpoints. I haven't done all the learning checkpoints, but Ratatouille, we've seen it. I've built a little project with it, Tokyo Process Streaming also. So this is what I use in this project. I use also the channels, spawn and stream. The KubeRS controller, I didn't do it. So it's good to have a checklist of what you need to learn before starting your project. And here the TDD, test-driven development. So I didn't do any test-driven development. This wasn't the target of it. State machine representing every high-level steps. In an enum phase, this I have implemented, something that looks like that, so I can validate this step. So different design decided. So I have decided different design, but I've used those enums. Ratatouille basics, build static layout, then refactor to redraw. This I've seen it during the first little app that you have built to read the file, providing an input parameter in the CLI with the path of the file and the error bubbles. So I still need to improve my error handling, management and everything. So I didn't do it. I might do it probably in year 20,690. But here I'm just using something else that I'm going to talk about in this video later on to manage those errors. And here, no TDD, no test-driven development in this project. Tell you the truth, I don't like those tests. I don't like to write those. So this probably, you give the code to an AI, and after you tell the AI to just cover those edge cases to make sure that if you change your code, it doesn't break everything. So here, this one, I just put a big cross to say I didn't do it. I'm just going to update my checklist live here so that you can see also down there on point 11 there is next. So that are the real steps that I've done, and I've done more, but those are between commits, let's say. So no TDD, to do probably, or probably not. Error handling with bubbles showing in the TUI and everything to make it like an amazing TUI. But I'm happy with minimalistic stuff as soon as I learn and I understand what I'm doing. Okay, so those one here like that. And after the KubeRS, I haven't done it. So I didn't want to use a lot of libraries in my project. I wanted to be minimal in libraries to to have even my own libraries. That's why I use this folder structure with workspace and everything. So that's why I didn't use it. And spawn and stream, this is done. Okay, now let's go into the improvement. What I haven't done actually. I just put here a little list of those stuff. So retry on failure, meaning listing more errors, edge cases, and having contingencies for those. TUI, scrolling logs, instead of having just a buffer of determined lengths of number of lines. Use receive to receive the first line, just to make sure I receive everything, and after try receive to catch all the other lines. But I don't like this design. So as I don't like this design of nesting a try receive inside a receive, I just use try receive. Have more targeting state to make the backend more robust and reliable. I have a lot of states, and that helped me to understand how to use those states. But doing a little bit more of those would be nice, and make the user input part, having more interactions, more steps. For example, covering some cases when the user enters a version that doesn't exist, but is not for the user, it's for me, so it's fine. Show more information in the TUI with, for example, a spinner showing that the step is in the process. Yes, for the moment I'm just using a string saying in process, but it would be nice to have a spinner or something like that. I put down there, but I will not do any of those. Moving step by step in Rust learning is fine. But this one actually I might implement it in a future video, saving one of my upgrades for that. And after I also put a line, copy and paste the full project on the AI, like a ChatGPT or any of those, in order to get more suggestions. It can be nice to use an AI, put the code in to get those tests done. Please like and subscribe during the break. We're gonna have a little break, and after we're gonna go into those 15 steps. Okay, just before, I'm just gonna update this very quick. As I've updated the macro, I fixed an error that I got. Okay, this is done. So, the first lesson. Out of the 15s, use apt-get instead of apt. So apt is a wrapper. apt-get is more reliable, and I get less errors using apt-get in my commands. So I'm just going to open one of those files having those comments. The streaming one, that's why I'm passing here apt-get with a Y, because I don't want any interactivity. I don't want all those warnings coming from using just apt, because I'm trying to catch those errors, and those warnings, they go into those errors. And I use here -n for non-interactive, and make sure that beforehand you have set up sudo and vsudo to allow no password for the user, or just to allow some binaries like that. Okay, to upgrade consent binaries path, you can provide those so that you don't get any interactivity. We use also yes --yes for the GPG command, so that if another key exists, it will overwrite that key without any prompt asking to confirm, because we need to pull those keys depending on the version. So yeah, we need the keys, we need the repository also to be updated. So that's why we don't want all those validations to come as a pop-up on a non-interactive, like in any scripting that you would have done. So this is one of the first lesson. The second one, play with the awk, okay, the comments, to see how the output looks like. So here I'm just going to put H, how the output is missing U, but it's fine, looks like. So this also help you to pipe those comments in order to get that. Let me just navigate to the right section of my notes so I can see those comments here. For example, get notes here. I want to get the right line. I use the NR +2, +1, and so on. We can just use it here. You see, I get, for example, this first column with the node name, node 1. And when I change here, just let me do it like that. If I pass out n +1, I get the first row. So the third row here. Okay. And that's how I can get those node names. I can pass it. So you need to analyze the outputs. Outputs of errors, output of whatever you want to get in order to parse it just by using those pipes, so that it makes your life easy after when you want to save those into the states. Or even if I'm doing that, I'm using some parsing functions after to catch those lines, but still, this helps a lot. So let's take this one here, and we can also use it in the terminal just to see how I'm getting the version of kubeadm, for example. I'm splitting, and after I'm adding a key, kubeadm space, because I'm going to be passing on that key later on to save it in the state. So that's how it looks, the raw output of kubeadm version. Me, I want 1.31.9. Okay, so that's the one is going to be printed here, and that's the key that I'm using, because I'm going to be passing on that key, kubeadm space, later on. That's how I'm saving it to the state. Okay, so the V here, I'm just going to do it like that, just to show you what the command F is, capital F. Maybe I need to pass through the man of it. Can I grab the man like that? Let me check. No. So we can just maybe open the man and find the F. Okay, the key is at on the top. So the value, set the field separator. Okay, FS, field separator to value. So here the field separator, it's V. Yeah, so here I get the version. This is 6. So that's not the space. Space is 1, 2, 3, 4. It will be inside 5, right? But it's not, because I'm using the regex down there, which is going to be using those double quotes. Okay. So this one will be 1, 2, 3, 4, 5, and that's inside the 6. Let's we get it. Okay. And in the second awk, pipe to it, I just split on V. I just get what is after the V. Okay, field separator V. So this You need to play with that. It helps a lot to do this parsing. So that was the second step. The third lesson, let's go down. Let's put the U here for the output. And let's go down to the third one, which is take the chance to explore more REST utility functions like retain or TUVEC, because instead I was doing iter cloned collect, and after I was collecting in a vector, but you can just use TUVEC instead. Okay, just put all in one line here. And after I was joining, so sometimes I'm using that to print what is inside the vector. I join in a line return in order to see what is inside of it in my logs. So we can maybe navigate some files to find where I've done that. And it's more efficient to just use .2vec, just one operation, not 2 or 3 chaining operations. So I should have this here in the passing lines. Yes. Let me just copy one part of it. We're just gonna jump to the right line. No, it's not here. Here, TUVEC. That's something that I've used, and I've changed it from what it was before. Okay, and after I join, and after here, for example, it's not for the logs, I check if it contains a part of a string slice. Okay, so here, same. Here is to print the logs. Okay, so here I'm just commenting. Use TUVEC is more efficient and simpler. Simpler than using all this. So that's what I was using before. And now I just have the TUVEC. This makes your life easy. Also, I've learned about the vec underscore. This is just to collect on whatever is rendered in terms of type in the step before. And we have also retain. So retain is also something that I have discovered here, which is very helpful in order to do some filtering, because I needed to know which nodes have been updated and which nodes are still in the list of nodes to do, and I wanted just to filter out so that I don't do the same node twice, so I get rid of those updated nodes, those nodes which are already done, and that's how I get rid of those nodes from the list of nodes to do. I just use a one-liner and it does the job perfectly. We can maybe go to a playground just to play with it so that we can understand those. We're gonna maybe start with the retain. So we're just gonna create a vec just to see how we can filter this out and how it works. Mangakisa 109 Shibuya, and the B variable has another vector with Harajuku and 109. So after we got something like that, just after I'm gonna do for lm in the b dot iter. So we do an iteration on b, and after here you can do a while liner, but we can also do an iteration. So we're just going to use iter. We're going to see later on closures, but that's something that you can use here. I don't use X, I use location to tell you just you can put any word here. It's just going to be whatever it's inside the vector. So we retain not on B but on the A vector. That's the one we want to filter. So whatever it's an A, we want it to be different elements of what is inside B. So location is what is inside A, element is what is inside B, because we're doing an iteration over the B vector. Okay, and after we're printing A again to see if it has been filtered out, we need it to be mutable, because we're going to be cleaning it up doing this in-place operation. And yes, we got rid of 109, which is the common the common value. If I put equal, for sure it's not going to filter anything. And after here I can maybe play with it so that we can see how it works, because you can be also surprised by it if you're not following the right logic. So we can break it down here. For example, for equal, why we don't get anything, because the first check is Harajuku. When it's check Harajuku, and inside A, the vec A, there is no Harajuku. So it's gonna be getting rid of everything. So all is deleted. So the second check, when we check 109, it is already empty. So be careful with that. That's what I've learned also. So use instead a one-liner to check for equality. Okay? So let me get rid of this and do the one-liner. So here we go. So change in place. That's what retain does. And A is mutable. So we should get what we want. So location, A contains location. So A retain location, B contains location. So that's the other way around. And at this time we get what we want, the filter equal. Okay, 109. Not contain, so we get the reverse if you put the exclamation mark. Okay, that is why I prefer the one-liner when using retain. Okay, let's go now for the fourth lesson. Do not hesitate to have more states to break down the logic in small pieces and have the right fields in the right states, and do implementations and use enums to detect types, custom ones. So here we have all those enums that I use, for example, for the color, upgrade status, cluster node. No, that's a struct. So those ones here, these are the enums that I'm using. And after, I have here a huge file with a lot of states and a lot of implementations for each. For example, here pipeline state is going to be having a color field, which is using the enum step color, and the shared state, which is a struct. And after, we implement rules using those enums for the types, and define and waiting when I create a new one. And the color is gray. And after, we have some other implementation to update those fields. Okay, and the shared state here is this one, which has also an implementation. Here for the buffer, I just use an hash map, implemented display from the documentation, always the same kind of function. This is the new one with conditions to create a new shared state. After another one to iterate through and get those values. App state, the steps, the vect, the logs, ring buffer, okay, of string type, the vec of step info, which is a enum. And after here we have the ring buffer, iteration, the length of it, adding the new, as I'm using here vec deck is like a next, now and next, you know, like a queue. And that's how I manage the logs being shown in the TUI. I use here generics, the same type. And after I have more states here, the desired versions, target curve version, target container D version, the Madison pulled full version, that's a trick I used. But those fields, they're not here from the beginning. This has been evolving. So some fields came later on because you're working step by step, but you make sure that you can have states that can evolve. That's what is interesting in the phase at the beginning when you prepare the project. Okay, so it is evolving through the project. Let's just get rid of those lines. Okay, I didn't break my file. It's fine. Okay, and you have some more implementation, component versions here. I have another one, little state for that. I prefer to break everything down, but after maybe for performance, it's better to have a huge states, so you don't need your code to be visiting 100 states before deciding on an outcome. So this I can understand it, but this is a good way to learn, to just break down into small pieces. And you have your enums here, not a lot of those, but just what is needed for the application. So the lesson 5, abstract away concepts that you still need to learn, like using errors, as I told you. So that's what I'm using here. Also, because we're using a TUI, when you use the ePrint for errors, you won't be able to see those prints because the TUI is covering the terminal screen. Okay, so that's why you need to use a file for that. You're gonna log all the errors in the file, and you're gonna use an abstraction of error handling using anyhow. So here that's what I'm using, anyhow result. And that's here I don't use it the best way in this function, but yes, in this function here it's okay. It's gonna render a result like that, or return an error, and the error is formatted by the anyhow macro that I'm using. So basically what I do in this project, it's a sequential steps, so I want it to fail, but I don't want it to panic. So that's why there's no unwrap, but I want it to fail and show what's the error so that I can fix it and make sure the step is robust enough to just keep this sequential process running. And I log in a file at some strategical areas, functions, in order to know what's going on, just looking at the logs, so that I know where I can go to fix those errors. But you see, every time I try to return an error. Okay, just to invalidate quick, fail fast. And here we can maybe go in engine and just check if the engine I used anyhow. Yes, anyhow, I just imported it from the top. So you will just see a result here. So result. And after somewhere, I'm returning an error here in the function. But here we can just see what I said about ePrint. Okay, so this is a custom function made to get some logs, as the TUI doesn't permit to see println, ePrintlns. So we write it to a file. Okay, and that's my function, print debug log file, and that's it. And I put a let underscore for the compiler to be happy. That's what I used before, ePrintln, but it doesn't print anything. Okay, this one because of TUI won't work or is covering by it, so can't see it anyway. That's my comments for me. The sixth lesson. So this separator, this is not or just boolean. It's just a boolean actually, true or false. So for comparison, it's better to use dot contains or matches. Okay, so that's what I've learned from that, because I always try to do the Pythonista way first. I find that it works well with Rust, and if it doesn't work, I need to go to documentation and see how Rust does that. Okay, so I've written some comments about that somewhere in this file. Try to use the regex to find it. Here, do not use this pipe for comparison. Check if something is matching, like A or B or C equal var. So this is a boolean, true, false. Use matches or contains. Okay, so here you need an ampersand for that. Let's play with it a little bit. So we have here Kilimanjaro. Let B, A contains Jaro. And let's print the B to see what is going to be printed. What did I do? Okay, there's a T here. True. You see, it's just a boolean. Just say if it is true or false. So contains is a bool. Matches. We can do the same with matches. A. Matches, it says false because it doesn't check the same. So matches is also a bool, but need to match 100%. So I need to have here Kilimanjaro to get the true. Okay, it's a nice macro. Now using odd statements, or now you can use the pipe. Okay, or Everest. And after you run it, this is true for sure. I get rid of I just write Fujisan, false, because there's no Fujisan written here. Everest. Let's run it, true. Okay, so you can use after the pipe like that. And you can put more. Or you can use contains, but in this way. Kilimanjaro at that contains Everest. Ampersand. True. Okay. So let me here just put a W, completely different, false. Okay, that's how you're gonna be comparing. False also for key. So it has to be the full word here also. Okay. Oh no, it's because I did the wrong way. This is this way. Other way around. Put the K down here. It's fine. Okay, so dot contains. That's the lesson. We've seen content and matches, but what about closures? I've used one with location just before. But I can show you another example again, as this is a part of this lesson. It can be very helpful to manage your shading of comments using closures to do the job for you. The map function can help a lot for that. That's a function that you're going to be using a lot. Okay, so you do an iteration. After we map on those values and we transform those values. Okay, so we have seen contents and the matches already. So close yours like that. Now let's see. We're just gonna play with a vector so that we can iterate through. Walk in to string, and here dancing in to string. And after we can use here a variable. Inside the variable we're going to be playing with a iteration. We clone those variables so that we can play with it, and after nanny we just do some stuff with it. So here I just put it like that, whatever is inside A. So that's what you get here in the closure. So you put whatever name that you want, which is meaningful to you. And this permits to play with it. So now we can do whatever we want inside with that variable. If whatever is inside A contains walk, we want it to be concatenated with in Shibuya. Else, so if it contains in Ebisu, to concatenate it with in Ebisu for anything else. After we collect in which type string, and we print B. Okay. So let's see what we got. Okay. I need an underscore. Here, underscore. Okay, walking in Shibuya. Just let me change the sentence, but you understand the gymnastic behind that. Is that using closure helps you to play more with those variables. Let's have a little break and breathe a bit. We have some few steps to see. Please like and subscribe during the break. We're improving a little bit more. We have seen the 7, so let's go for this one. So if and else rule. If block type returned, if block type return type have to be the same as else type, as else block type, and the if else return for the function must match the function return type. If without else, when used in an expression, doesn't work, so you must provide an else side for the compiler happiness. So sometimes, like when you use let variable if, it will fail if it is not returning nothing. So if it is returning something meaningful, the compiler will cry. But to explain that, I think it's better just to go to the playground and play with it just to show you. So we're in the playground. Let's create a variable A. It's a string. It's Fujiyama. We use the expression directly to show what I meant. So let B equal if A contains Fuji, A push underscore str space maintain, and we just try to use an if statement. That's it. And say B is equal to A, but no. It says here, if expression without else to evaluate, to use the parenthesis, meaning nothing. So here we provide the else side. Okay, not a mountain like Fuji. Okay, so you see here, the types are different. A is a string, and here it's an ampersand string. So it's not going to work, so I put the to string, because this is part of those rules of the if statement. So it needs else side, and they need to be the same type. So this is what it was before. That's why we got that error, because part of those rules, we need the if block type returned and the else block type returned to be the same types. And after it becomes string, so at next run it should print and work. I cannot borrow, so I just put a mutable because we want to mutate it. Let B a Fuji intentional. Okay, this is B. Okay. Let's say we're not using B. I don't want to use B. Yes, maybe I should print the B. So here on the score, you can't just follow what the compiler is saying. If I put on the score, there's nothing, because we're using let B. Let's get rid of the underscore. And let's not follow what the compiler is saying, because what we want to do, we know. We want to print B without any typos. Okay, now we got it finally. So Fuji mountain. Let's put another Dyson, another volcano. Not a mountain like Fuji. So now it works. It works fine. So now let's get rid of the variable. Let's print A. So we have mutated A. A push, we're going to push this str into it. Okay, so now we're doing the in-place mutation, and after we're just printing A. And this works fine also. Okay, so those are just in-place operations. So they evaluate to nothing actually. It's not returning anything meaningful. So this is going to work. It's like when you use println, it's the same. If I just use a println inside of the if block or the else block, it will be just easy. So here I'm just going to add let mut B. We're going to push to B. We found Fuji sun. And here I'm just going to push to B. It is not. So where is Fuji-san? Because I just put contains Dyson. And now I try to return B every time, which is something meaningful, right? Returning same types, both strings. Is a string. And here we want to print the B. So here we try to follow the rules. What does it say? Expected, return nothing, return nothing. So let's put a little colon in front of the B. Here we just returning nothing already. So now it's going to work. It's just telling us that we need to clone it because we have moved the variable. So here is a moment in which you can follow what the compiler is telling you to do. We run it again. Has printed the one outside of it. We didn't get yet what is inside, but it went with where is Fujisan. So it works. And colon or not colon at the end is the same. When you use println, for sure it's going to work because this is not returning any type. So you won't get any trouble, just to show you. But you still need to clone it here. And here we can do the same. Just a little gymnastic, just playing with if-else statement to understand that, because I didn't get it 100%, so I got some trouble with that. So I needed to make sure I understand what's going on. And that's what my learning is about, those if statements. Okay. So now we're good. So the lesson 9 for bash SSH command, not necessarily need those quotes, double quotes, single ones for commands to run. So it's also fine to just write the command straight away after. That's what I've learned. Because with those quotes, I got a lot of issues of interpretation in the REST side. Especially that I'm using format a lot. And with those awks, commands, piping, there are some curly braces, so it becomes a bit crazy. So you see here, I can just SSH to my controller node from outside. Using the quotes or without the quotes, it's fine, it works. So I just decided to not use those. I can chain the command also to it. I can grep eng to get engine, for example. And it's going to work. I can also do an operation and in this engine folder and just check how big it is. Takes some time, but I got the answer. So keep that lesson in mind. Helps me a lot. I got some trouble. I could fix it like that. Lesson 10, understand receive versus try receive, which can create some race conditions that makes some event not being received, while received will make sure that those will wait indefinitely. So we need also contingency for that. So make sure it's received, but if there's nothing sent, or if you send something empty, you will get some trouble with that. So you will have to make sure you have a join or something that just stop that process of waiting. Okay, so try receive state. No, that's not this one. I have a comment somewhere about that. Just let me search it here. Race issue. Got some events not being received in the stream, even if I had run properly. So the solution, I've changed it, the try receive to receive, to make sure it's blocking and waiting those events. But ChatGPT told me that I should use receive to make sure the first line is received, and then try receive to drain all of the other lines. And if nothing is sent, to use a timeout system to make sure I exit the loop, as receive would indefinitely wait. But I will not do that. So I've decided to not do it because I don't like this way of doing. I don't like it, and it seems stupid to me. So I will just keep the try receive. And even if I miss some events, I got them on the logs. So as soon as the app is running fine, it's okay. Because what I'm missing is because I'm skipping those steps, because I don't need those steps. So anyway, if they don't show up in the TUI, it's fine. Okay, so that's what I've decided to do. So in Rust, it's different from Python. You need to slow down the stuff to make sure everything works well. So you need some timeouts. I mean some sleep time sometimes for that. So the logs are sent via take send, and after we call the run function, we use the try receive. But sometimes through the channel, it can be empty at the moment, so it skips the entire message queue for that step. So there's some cold race condition happening. It's well known. So we can go maybe in the function. Okay, so here we're just initializing those states before passing those into the big loop. We run an update. We match on that. After here, we try to break it. We use a sleep here, for example. So I put a little sleep, but so I have to put some sleeps in order to make sure that some processes like the nodes being ready. For example, because between upgrade plan, upgrade apply, sometimes the process or the jobs running are not all complete. So I got some errors because of that. So I needed to slow down that Rust blazing fast, amazing process. But I didn't find the way to do it in another way, because I'm using try receive. So those sleep time were just fine. Okay, so here you see sleep. I just went back to it. I'll try to check if I have another place where we can see it in a better way, because I have commented it here. That's the one. Yes. So we'll be following the order in which data is sent to channel and received in order. So that's the transmitter, TX, and the receiver logs. So here I get the right order. It's very important. And I make sure that it's a sequential like that. And after I run my steps, okay, when I receive a line, that's when I try receive. Try to get those lines, and at every steps, important ones, I try to play with those lines, with the content of those, to update the states or the TUI, or to redraw, reprint the TUI. Let me see in the logs if I can find a case of that. I know that between drain and cordon, sometimes I don't need to do it because for the controller node, because I have only one controller node, it needs to be alive. But it's fine. You'll see that in the next videos when I'm going to show you the app running and we're going to visit the logs together. So the step 11, use sleep time trick to get event received. Yes, and to give time for the cluster to recover state before next step. So I showed you here sleep in the process of the application, the logic of it, but in some comments, very specific ones regarding the different steps, I use also some sleep comments. Okay, so we sleep a bit to give the time for the node to be ready. As I told you, I get frequently node not ready, and the step fails actually. So it hits the error side of my logic. So I get the trouble for that. Okay, now we go to the 12, almost in the same topic. Use a loop or some sleep time to wait for the node to be ready and for the health check of pod to complete its job. So you see I got a lot of trouble with that. So when you're going to be playing with streaming channels, you're going to get this kind of issues. Okay, so step upgrade plan and upgrade apply, too quick. I had several times the node not being ready. So here it's because we have a race like condition. When the step is done, it needs a little delay to be ready, especially that there are some health pod, like there are some jobs running for the health check. So the solution I have added in the plan and apply steps, so the sleep time and also the loop, a little loop, making sure that we can run the command kubectl get nodes to make sure it's ready. It can be even more robust, so passing the output of that, analyzing the past output, but I didn't want to make it that hard. So do sleep 60. For example here, this is the upgrade plan. I just use a sleep of 60 seconds. After you have some little tricks in order to escape those errors that are not real errors, they're more warnings. But in my code it's going to be, it's going to become an error. And here I just use an until loop. Okay, I have also a downgrade. So I can go one version down. I've incorporated it so that I can play with the same version until it works. So until kubectl get nodes, I push it to dev null and I do sleep 5 seconds. Lesson 13. Tuple index are not accessed like in Python. Index. Use dot notation. So this I need to show you. So here we have, for example, a Python. I'm using here a Python interpreter. So SVG, A1 is V, A2 is G, but this is not working in Rust like that. Okay, we can't use it this way. For tuples, this is the Rust side. Let A, just going to create a tuple with some different words in it. Let me just think at nice words. Komazawa, Meidai and Yokohama. Okay, we have those neighbors in Tokyo. Let me use the Pythonic way. Let B, A, and after I take the index 0. No, doesn't want that. No, it's not because of that. Print. Get a typo. Okay, now it's showing us access, but the compiler is amazing. So it's telling us how to do it. The Rust compiler shows that AI can be a scam also. Because this looks like an AI answer. You just use a dot. Okay? That's the lesson here. Alors, 14. Do restart kubelet and containerd services before important steps like upgrade plan and apply. So need to restart the services. Otherwise you're going to get some troubles that are already fixed. So you see here, before doing all of that, I do a sudo systemctl restart kubelet. Okay, and after I run my little loop, and I do the sleep to make sure it's running. And the last lesson, use timeouts, but different ones for each steps. So it's very important to use timeouts, especially when you're playing with streaming and the channels you try to receive. So you don't want to run indefinitely. So you give a time limit to those steps. If the time limit is hit, that step fails. That's what you want. So here I'm just returning an anyhow error. For example, discover node, I put 60 seconds. In some of the steps, I have a lot of installs happening. So, for example, here I give 360 seconds. So a little bit more than 5 minutes, 6 minutes. And after here, I go for the upgrade plan. Give it some more time. Okay, because Kubernetes timeout is defaulted to 5 minutes. I add 150 seconds for the other installs. Same here, upgrade node. Restart the services, just 30 seconds. This is event, it's a lot, but it depends on your resources also. So depends on your computer, how much resource you have. So you need to analyze that, know how long it takes. Okay, those are timeouts before the step fails. Okay, so always fail fast, but fail at the right moment. Nice learnings. They were actually more like the channels or the send and sync types implementations. We have seen at least 15 lessons from this project on what could have been improved. It is minimalistic application, but does the work of discovering my Kubernetes cluster and upgrading the nodes, adapting to their types, controller or worker. In the next video, we are going to dive into more details, especially what I've learned about the TUI front-end side this time, and how you can divide it and show the data that you want in a specific area of the screen. Okay, let's stop here. Hope that you like this video. Please like and subscribe, and see you next time.